Today, lesson 3, decimals and percentages. Hopefully, a lot of what we covered today will be quite straightforward because it's merely building on what we did last week, and at the end of fractions we actually dabbled in a bit of decimals, and hopefully percentages won't be too difficult once you get this idea of what it means. Okay. So what are we doing today? We've got 5 learning outcomes. We're going to talk about decimal notation and convert from fractions, which is building on what we did last week. We're going to talk about percentages and the meaning parts per hundred, what that actually means and what it looks like in maths. We're going to interpret fractions, decimals and percentages as operations. So we've already done that for fractions in so much as we add, subtract, multiply and divide fractions now. What we're going to do is do the same for... we're then going to calculate fractions, decimals, percentages. That's with respect to of amounts, okay, or percentage increases and decreases. And then finally we're going to order rational numbers. Don't worry too much about that. That's something we've already started, and it's just comparing fractions, decimals and percentages. It's a fancy term, rational numbers. It just means numbers that can be expressed as fractions. The only number that you come across in this course that is not rational is pi. Okay, that's an irrational number because it goes on forever and you can't express pi as a fraction. Okay. So, the big scheme of things, we're in week 3. Again, the 3 colours, because it's one of the 6 basics. Decimals and percentages. Okay, units 1, 2 and 3. Really heavy on unit 2 with this one. As you can see, we're at 3 out of the 6 already before we get to this continuation assessment. Hopefully, these basics are going in. If they aren't, please use the resources that are available on my course on YouTube. So your smart recap, just to get your brains ticking over, 3 questions based on what we did last week. So let's see what we can remember. So I want you to divide 2 fractions, and there was a technique for doing that. These 2 questions, 2 and 3, definitely relate to what we're going to do today. And it'll probably speed up the first half of the lesson if you can do the 2 and 3 quickly. So what is 0.36 as a fraction, and what is 2 over 5 as a decimal? Okay. Well, let's go through them slowly. No pressure on anyone. Anyone can remember anything, shout out. I don't want to put you on the spot. So the first one, can anyone remember the process for dividing fractions? What the steps were? Inverse, good. Flip. Yeah? So we flip what?
The divided 2 times and the 3 and 5.
So the divide changes to a times, and the 3 and the 5 are the things that we flip. Brilliant. And then when we get a multiplication of fractions, we know that's our easiest thing to do with a fraction, isn't it? Which is top by top,
5, 6.
bottom by bottom. 5, 6. Everyone happy with that? Okay. If you didn't get it because you weren't here or something didn't click, don't beat yourselves up. We'll keep going over these things. Okay. The reason we do these smart recaps is because they're going to relate to the lesson. These 2 are really important. So 0.36 is a fraction. What does 0.36 mean, did we say last week? Brilliant. It literally means 36 over 100, which we know better than that now. Can simplify it because they're both even. So what's the first one it can go down to?
18.
Good. You can break it into steps. You don't get any bonus prizes for doing it in one go. Again, we've got even numbers, so...
9 and 25.
And then... anything else? No. Because there isn't a number that goes into 9 and 25. Okay. Conversely, 2 over 5 as a decimal. And last week we covered 2 ways of doing this. Okay. We had our mega word in fractions, which is equivalence, or you could actually do what that says. So which way would you like to do first?
2 divided by.
Good. So this literally means in mathematics 2 divided by 5. Okay? And when I do that problem, in other words, I have 2 and I divide it by 5. 5 doesn't go into 2, so we put a decimal place, carry the 2 and borrow a 0. 5 goes into 20 4 times. So that's the good way of doing it with respect to mathematics, because that's what 2 over 5 quite literally means. But then there was the clever way we showed you last week, where we know decimals are tenths or hundredths. So if we make the denominator 10, we've done what to get from there to there? Multiplied it by 2. So what do we need to do to the top? multiply it by 2. So in the same way, 4 over 10 is 0.4. Yeah, that's what 0.4 literally means, 4 over 10. Okay, and we showed you the two ways of doing that. Fantastic. So what we're going to do is carry on where we left off last week, which was talking about this relationship between tenths, hundredths and thousandths as our decimal places. Okay, and last week we said if we had 0.3, it meant 3 tenths, and that if you had 0.06, which comes up an awful lot, it means 6 hundredths. And they'll try and catch you out in lots of ways with things like that, which you'll see in a minute with an example. Okay, so ordering decimals, you need to know the order of a decimal with respect to size. Now, people sometimes see 0.28 as bigger than 0.5 because they see 28 and they see the number 5. Remember in lesson or in the introduction we talked about misconceptions. So people have misconceptions of what the decimal places mean. So you need to understand that 0.5 is bigger than 0.28. 0.06 is the smallest because it's 6 hundredths. That's 28 hundredths. This is 50 hundredths if you were talking in the same way, if you were comparing. Okay. So, a little sorting exercise on the I2. What is the smallest number there then? 0.375. No, got 0.125. 0.04 at the back. Can everyone see that? So this is the smallest number because it's got no tenths and only 4 hundredths. Yeah? The next smallest. Good. 0.125 is next. Where should we go next? Good. 0.25. 0.375. So can you see how that works? Yeah? So the important thing to remember here, and they will test you on this when you're ordering decimals, is that just because it's a bigger number, it looks like a bigger number, like 125, and you're comparing it to 4 or 25. That's not necessarily right. You have to look at the tenths, the hundredths, and the thousandths individually and work from left to right. So there's a 0 there, a 1 there, 2, 3, 4, 7, 8. Okay? Happy with that? And that's a major misconception with decimals. So, where do we come across decimals then? Let's talk about where we come across decimals. Obvious place, money. Money, absolutely the biggest place where we come across decimals every day of our lives. In the exam, it's no different. They will give you decimals as money a lot of the time. They'll say something costs 65 pence and you buy 12 of them, just to test how you manipulate decimals, and we'll see that in a second. Where else do you come across decimals? Things that divide up into point, something. Measurements, perfect. Measures, yeah? If we were measuring the length of something, there might be a point in there. 1.25 metres, how tall are you? 1.73 metres, I believe I am. Okay, so measurements, perfect. Not measurements on just lengths, but also weights, okay? Capacity, and what else? Distance, yeah? Lengths and distance, kind of the same thing. So we've got distance, we've got weight, we've got capacity, and there's something else that we measure.
The temperature.
Temperature, perfect. One more. That's important. So temperature, good. So temperature might be 18.7 degrees or whatever. One more on there. Or was it 96.4? Is that nurses in here? What's the body temperature? 37. That's new money. I'm old-fashioned. Is it 96.4? Anyway, there's one more. Remind me not to get ill in this class. Right. So, what's the last one that we're looking for, do you reckon? That might have decimals? Sorry? Brilliant. Speed, which you measure with distance, and time. So time can have decimals. There's a bit of an issue with time. If we're running the 100 metres and I say it's 10.384 seconds that I run it in, brilliant, I haven't got an issue with that. But if I say something takes 1.5 minutes, how many seconds is that? What's 0.5 of a minute?
30 seconds.
How many seconds?
30.
30 seconds, perfect, yeah. So when you're talking with decimals with minutes and hours and time, there could be an issue. And later on in the course, when we get to measures, we'll look at decimal time and all the ways, nasty ways they can catch you out with decimal time. Yeah, decimal hours or decimal minutes are their favourites. Okay, but that's good. So that's where we come across decimals. Perfect example from an exam. What is 5 pence as a fraction of a pound? Have a go at that one. So what's 5 pence as a fraction of a pound? What's the question asking? Good. But we never quit there, do we? No, we don't stop there. So what's it really asking you to do? Simplify. Good. So what number goes into 5 but also goes into 100? 5 goes into 5 once. 5 goes into 10 twice, remaining to 0. So that's what it was after. So what might look like an innocuous question is asking, do you understand decimal places with respect to pounds? And then can you simplify from a fraction, okay, down to 1/20th? Good. Right, so what we need to do now is make sure that we can do our 4 rules of mathematics with our basic signs, okay, with our decimals. So I'm not going to teach you to suck eggs, I'm just going to talk about the processes and then get you to do so. So, adding decimals. Everybody do the column method with this. Yeah? Just line them up, 2.4, 1.7, draw your total line, 7 plus 4 is 11, carry the 1, put your decimal point in, 2 plus 1 plus 1 is 4. Everyone happy with that? Yeah? Those lovely square books come into their own with these. Okay. Let's have a look at the subtraction. Exactly the same process, 3.2 minus 1.8. So the biggest number has to go on the top for this to work. Put your total line in. 8 from 2 doesn't go. It's not big enough. So we convert the 3 into 2 plus another 10, because 10 tenths is 1. 8 from 12 is 4. 1 from 2 is 1. Don't forget your decimal points. Okay. Everyone happy with that? Nice, straightforward column method for adding decimals. If you do it the other way, where you break down the whole numbers and then you break down the decimals and then put them back together again, that's up to you. That's quite convoluted. It's kind of easier to do things like this. Okay, everyone happy with that process? I'll let you do a couple then. So 3.12 plus 14.39, and this is one of their favourites. 20 minus 17.68. Why do you think I've written that there? Money, yeah. £20, isn't it? Right. Let's look at the first one then. We've got 14.39. We add 3.12. 2 plus 9 is 11. 3 plus 1 plus 1 is 5. 4 plus 3 is 7. And a 1 there. Happy? Happy days. Good. And then the 20, no different. You can put the £20 up. So you put your 20 and you're taking away 1768, and then a lot of borrowing happens if you do it using the borrowing method. So the 2 becomes a 10, that becomes a 1. You borrow from that, that becomes a 9, that becomes a 1. You borrow from that, that becomes a 9, that becomes a 1. And then it all falls into place. 8 from 10 is 2, 6 from 9 is 3, put a decimal point, 7 from 9 is 2, and 1 from 1 is 0. So £2.32 is your change. Okay. So, cost of hot drinks in a cafe are as shown. Tom buys 2 hot chocolates and 1 tea. So you've got 2 of these, that's 4, plus 1 of those, 5.25. It's 2 marks. So just writing 5.25 because you've done it in your head, just throwing one away. What they'd like to see is the £2, the £2, and the 1.25. Do something like that for them, and that's your second mark. So don't go throwing marks away or being overly clever because you can do these things in your head. So here, the perfect one, the thing that I warned you about in the last slide, you pay with a tenner, what's your change? And there are again 2 marks, so you've got to show them some kind of process for doing it. So you put your £10 there, You put your 525 underneath. You do all your borrowing, so that's a 0, that's 10, becomes a 9, that becomes a 10, becomes a 9, that becomes a 10. 5 from 10 is 5, 2 from 9 is 7, 5 from 9, 4, and on your answer line, you write it. Yeah? Give yourselves a big tick if you've got that. So that's 4 marks, question 6 in the exam, so just under halfway, and these are the kind of questions you're expecting in these papers. Right, let's go on to the fun stuff. Let's multiply with decimals. Anyone got a technique for multiplying with decimals? Anyone know how to multiply with decimals? Okay, let's do something that we might know then. 6 times a half. We kind of did this last week, didn't we? What's 6 times a half then? If it's 6 times 2, you'd expect it to get bigger. So 6 times a half, you're expecting it to get smaller because it's less than 1. So 6 times a half is 3. So let's talk about how we get 3 from that. What process can we come up with? Anyone heard about getting rid of the decimal points and then putting them back later? That process? No? I'm going to show you the easiest way to deal with multiplying decimals. And this one later on is where everyone gets wrong. This is the one they put in the exam. Okay, this one here is the one they put in the exam. And the reason people get it wrong is because they don't do the decimal place rule. Okay, so let's show you how it works on the easy one first. The easiest way to deal with decimal place multiplication is move the decimal places so the numbers become a whole number. So if I move it one place there, that becomes 5. Okay, but remember, you've moved it one place. Do your basic maths. 6 times 5 is 30. So you end up 6 times 5 is 30. And then move that decimal place back the way 1. Because you moved it 1 that way, you've got to move it 1 that way. So your answer is 3. Okay? Can everyone see what I'm doing there? I'm moving that decimal place around. It's not politically correct in mathematics, and I'd get slated if I was teaching A level about moving decimal places, but certainly for foundation level, you can say, I've moved that one place to make that the number 5. Okay? In a sense, you're multiplying it by 10. You do your basic math, 6 times 5 is 30, and then you divide it by 10. In other words, move it one decimal place back the way, and that gives you the answer of 3. Okay? So I've shown you the process with a straightforward one. Let's try that process on this one then. Okay? So we'll just clear that up a bit. So my process says what? What do I have to do? Move the decimal place how many places? 2. So if I just keep a track that I've moved it to, I'm now looking at a basic sum that says 3 times 12. Can everyone see that first step? Yeah? I do 3 times 12, because I know my 12 times tables, it's 36. So I've now got 36. What have I got to do to get back to where I was? Move the decimal place 2 places. 1, 2. Yeah? So the decimal point lives there. So 3 times 0.12 is 0.36. Yeah? Isn't that nice and easy? Okay, let's try it on this one, because this one catches almost everybody out in an exam. And I can almost guess, if you were just going to say an answer without doing the process, I can almost guess 90% of you would say 0.8. Let's do it with the process. What do I have to do my process? Move that one, but I've also got 1 there as well. So I've got 2, but I've got to move it back. Do the basic maths. I've left the sums nice and easy. I've got 8. So how many places do I have to move it back? 2. So it's not 0.8. As Jenny was saying, it's 0.08. I can almost guarantee 90% of students early on in a course would get that wrong because they're not applying the rule. They're just looking at 4 times 2. They're seeing the points and they think it's 0.8. Okay? The rule is I've multiplied that by 10 and that by 10. So that's to multiply it by 100, and you've got to divide it by 100. In other words, move it 2 to the left. Anyone struggling with this concept? Because it is by far the easiest way, especially in Unit 2 where it's non-calculator, and they will give you numbers like this. They're not trying to trick you on hard sums, they're trying to see if you know a process. And the numbers will look like this. Okay? Do you know the process? 2 to the right, 4 times 2 is 8, 2 to the left. Do you want to try some? Yeah? Have a go at those two. Make it difficult, but just try the process. So 2.1 times 0.4 and 12 times 0.02. So the first one, what we're going to start with, what we're going to do first. Move the dots, decimal points, 1, 2. Everyone happy? We're going to move it 2 spaces. You might want to do that. I used to do that as a kid. Put a little 2 up there so I remember how many to move it back. Now we're looking at 21 times 4, which is 84. Not hard maths. Now what do we have to do? Move it back 1, 2, because it's living there at the moment. So it's 0.84. Everyone happy with that? Yeah? Good, isn't it? Good stuff, this maths. Let's try this one then. I buy 12 lollipops at 2 pence each. Could look like that. Okay, so what am I going to do first? 2 places, so I keep a count. Becomes 12 times 2, which isn't hard maths. And then back 2, 1, 2. So it's 0.24. Happy with that? Okay, good. Good. Right. Dividing. When you divide fractions, the trick here in Unit 2, doesn't matter in Units 1 and 3, you've got a calculator, just do it. So when you're dividing decimals, the trick really is to make the thing doing the dividing a whole number by moving that decimal point again. But it's all about equivalence. If you move this one by a factor of 10 to keep the fraction the same, what you do to the bottom, you do to the top. Because in a sense, if we look at this one here first, 12 divided by 4, everybody should know it's 3. Yeah? Okay, and as a fraction, it says that. So if I divide 120 by 40, it's exactly the same problem, isn't it? That's what we spent last week talking about, equivalence. Well, it's the same for this. If we do this as a fraction, and I know we shouldn't mix these things up because decimals and fractions aren't the same thing, but you could in theory write that. If I multiply the bottom by 10 to make the thing doing the dividing a whole number, to keep the answer the same, what do I have to do to the top? Multiply it by 10. They have to be the same, yeah? I still get the same answer because it's still equivalent, isn't it? So the trick with dividing decimals is to make the thing doing the dividing a whole number by multiplying it by 10 or 100, and whatever you do to that one, you have to do to this one to keep it equivalent. Okay? So let's have a look at 1.2 divided by 0.4. 1.2 divided by 0.4 is exactly the same. If I multiply that by 10, it becomes 4. If I multiply this by 10, it becomes 12. So 1.2 divided by 0.4 is exactly the same as 12 divided by 4, which we said gave us 3. And that relies on this equivalence thing we were talking about. Sometimes, so I'm going to show you these two again so we get the process, okay? So what I'm saying is the thing doing the dividing, okay, which is the denominator as far as a fraction is concerned, you want to make that into a whole number. To make that into a whole number, we move the decimal point 1 place to the right, and it becomes 3. If you move that decimal point 1 place to the right, you have to move this one 1 place to the right to keep it equivalent. So as far as mathematics is concerned, 9.6 divided by 0.3 is exactly the same problem as 96 divided by 3. Does that make sense? Mm-hmm. Yeah? The odd smile and nod, because we did that quite a lot last week. So if we then do 96 divided by 3, 3 into 9 3 times, 3 into 6 twice. So the answer to that is 32. Does that make sense? It's not magic, we're just using equivalence again.
Would you not have to go back again?
No, because it's the same answer. If I said to you, right, 0.4 divided by 0.2, and you did that on the calculator, it would say 2. Because 0.4 divided by half of its own value, 0.2, is 2, isn't it? So if I multiply this by 10 and this by 10, it's exactly the same as 4 by 2. It's equivalence. So you don't have to do anything to the answer because you've kept the fraction the same, which is what last week was all about. So if I multiply the bottom by 10 and I multiply the top by 10, I still end up with the same amount. So let's have a look at the second one, okay, and just do that process. So we've talked about the theory behind it. Let's look at this problem. So what did I say was the aim of when you're dividing with a decimal? Make the number doing the division a whole number. So I've got 0.4 and I need to multiply it by 10 to make it 4. Can everyone see that? Yeah? If I do that to that number, what do I do to the other number? Multiply it by 10, in other words, move it right one. Now I will get exactly the same answer when I do the division. So 4 into, oh blimey, I haven't got enough columns. 1, 2, 5, 4. 4 into 1 doesn't go. 4 into 12 goes 3 times. There's that decimal point gone. There, isn't it? Okay. 4 into 5 goes once, remainder 1. 4 into, and so on. Okay? Yeah, I could carry on doing the division. 4 into 14 goes 3, remainder 2. 4 into 20, 5 times. So it would be 31.35 would be the answer. Okay? I'll give you a couple to try that are quite straightforward. They're not as hard as that last one I just did. Okay? So just do the rules for those two and you'll hopefully come out with the right answer. We'll talk through them again. So I've got 2.4, I'm dividing it by 0.6. And I've got 8.6 and I'm dividing it by 0.2. I've got 2.4 and I'm dividing it by 0.6. Where shall I start? Make the divisor a whole number. So that becomes 6. What you do to one side you have to do to the other with a fraction, because that's essentially what it is. So it becomes 24 divided by 6, which is good. Okay. I've got 8.6 divided by 0.2. Make the thing doing the dividing a whole number. You have to do the same there, so it becomes 86 divided by 2, which gives us 3. Yeah? Happy with that? Do you want to try a harder one with a bigger number with lots of decimals after it? Because that kind of threw you last time. If I say, I don't know, 12.55 divided by 0.5. There you go. So I've got 12.55 and I'm going to divide it by 0.5. So don't forget equivalence. I'll give you a minute or so to have a look at it. So our process says I have to make the thing doing the dividing a whole number. So 0.5 becomes 5. If I move that or increase that by 10, I have to increase this by a scale of 10. This becomes 125.5. So now your problem is 125.5 divided by 5. So when you do your long division, 5 into 1 doesn't go. 5 into 12 goes twice, remainder 2. 5 into 25 goes 5 times. Put in your decimal point, 5 goes into 5 once. So you end up with an answer of 25.5. Typical questions where they're going to combine some of the basic maths you did in week 1 with other bits. Have a go at this. It's question 11 out of the 15 question paper. So this is quite far in the paper. Quite a difficult one. Can you read it? Basically it's to do with a gas bill. And they had 2 readings and somebody spilt their coffee over the rest of the bill. So you need to work out the number of units used, the cost of units at 30p a minute, the cost of units at 20p a minute, and then the total cost of the bill. And this is a perfect example how they're mixing up how you deal with large numbers and subtracting them, how you multiply pence with these numbers to come out with large numbers multiplying by 400, okay? How you deal with all that. So have a go at that one, break it down, and it's 6 marks. Very rarely get a question in a paper now that's worth 6 marks. Okay, this is the sort of question that catches some of the youngsters out because they've never seen a gas bill in their lives and they don't know what units are or the fact that their gas or electric are charged at so many pence per unit. Okay, let's go through it then, break it down into bits. So the first bit is asking what? 12605 minus 12134. Everyone happy with subtraction? Yeah? 4 from 5 is 1. Make that 5. 3 from 10 is 7. 1 from 5 is 4. So she uses 471 units. Everyone get that? Yeah? So that's 1 mark in the bag. Trying to work out what 6 marks are for. It says that the first 400 units are charged at 30p. So the first thing you do is you say 400 are at 30p and 71 are going to be at 20p. So we split that up. That's probably another mark. Now we need to do the maths to say what is 400 times 0.3. So here we can combine some processes we've learned. Move that one place and remember it. Do your basic maths. 3 times 4 is 12. Put the zeros back and then you need to move the decimal place one place that way. So that's £120. Everyone get that for the 30p rate? Yeah, so 400 units at 30 pence is 120 quid. And we're doing nothing that we haven't done in the last 3 weeks. Bit of subtraction, got a big number 400, multiply by a decimal which we turned into a whole number, and then we move the decimal point back. And then finally, I've got 71 units times 20p, which is 0.2. So we move that one place, so it becomes 71 times 2, which isn't particularly difficult, 142. Okay, but then we've got one place that we need to move it back. So that's another £14.20. So 120 plus £14.20 gives us £134.20. That's 1, probably 2, 3, 4, 5, and that's your 6 marks. What we're going to finish off with our decimals with is this rounding. Now we did it with our integers a couple of weeks ago, didn't we? We said to the nearest, to significant figures and so on. But with decimals, we've got this thing called decimal places we're going to talk about, and significant figures still plays a part when we're talking about decimals. So we'll have a quick look at these. So decimal places then. When we talk about decimal places, we talk about to 1 decimal place or to 2 decimal places. That's all you'll need to know at this level. So when I'm talking about to 1 decimal place, I'm interested in the first decimal place. That's what it means. So if I'm going to round this number to 1 decimal place, this is what I'm interested in, and whether I stick or twist, as always, depends on the next number along. And as we said with integers, if it's a 5, you go up. It's a 5, so I go up. So to 1 decimal place, it's 8.7. Can everyone see that? Yeah. So if I was going to say to 2 decimal places, I'm interested in 1 2 decimal places. But our decision whether to stick or twist depends on the next one along. So here it's a 4, so I stay where I am. So to 2 decimal places, it is 8.65. The 5 doesn't go up. Yeah? So 1 decimal place means I want it to 1 decimal place, but I'm interested in the next one along. 2 means I'm interested in 2 decimal places. Happy with that? And they can ask for answers in decimal places or significant figures with decimals, especially in units 1 and 3, where you use your calculator and they start giving you nasty numbers on Pythagoras and things like that, and your calculator says 8.36 for it, they'll say to 1 decimal place or to 2 decimal places. So you will get good at this in units 1 and 3. Okay, so have a go. Write down the following number to 1 and 2 decimal places. 1 decimal place. The 5, the first 5, yeah. And what dictates what I do next?
5.
The next one along. And so what's that telling me to do? Go up. So to 1 decimal place it's good. Yeah. Sometimes called DP, decimal place. So to 2 decimal places then, what am I interested in? The 5 and the 5. What dictates whether I stick or twist? The 6. So it becomes to 2 decimal places 4.56. Good. Here's a question on decimal places from an exam paper. Question 8, halfway through the exam. Michael wins a race. His time is recorded as 5.36 seconds. Andrew comes second in the race. His time is 0.03 of a second slower. Work out Andrew's time for 2 marks, and then round Michael's time of 50.36 seconds into 1 decimal place. So have a go at those 2 and see if you can grab the 3 marks that are going in that question. Let's do this slow. So what's this bit asking you to do? Can you understand? I've got a time of 50.36, and because he's second, you've got to add 3/100ths of a second to it. So all it's saying is add 3/100ths of a second to the time you've already got. So the time of the second guy is 50.39. Everyone get that? Yeah? Because he's slower, it's going to take longer time. And then this bit, straightforward, what we've just done, rounded to 1 decimal place. So what number am I interested in if I'm looking at 1 decimal place? We're interested in the 3, and our decision is based on the... So we're going to round up. So it becomes 50.4. Yeah. Significant figures works subtly differently. Okay. If we're looking at 0.0254, so when we talked about whole numbers a few weeks ago, integers, we said what was the most significant figure when we were talking about a big number like... What's the most significant figure, did we say? The 3. Yeah? We said the 3 was the most significant figure. When we talk about decimals, especially decimals with leading zeros, what's the most significant figure on that number? Green number. Sorry? 200. Good. Brilliant. Yeah. The 200ths. Because zeros aren't significant. They're placeholders. Okay? They don't have a value. They're just holding this 200ths here. So the first significant figure is the 2. So to 1 significant figure, I look at the 2, but I base my decision on the next one along. So if I was looking at this number to 1 significant figure, it would be 0.03. Yeah? Because the 2 is the first significant number, and I have to round up because the next one along is a 5. If we were going to do it to 2 significant figures, I'd be interested in the 2 and the 5, and my decision would be based on the next one along. So you have your leading zeros, 0.0, the 2 doesn't change, but the 5, because of the 6, turns into a 6. So this number to 2 significant figures is 0.026. Good. If you get a mixture of whole numbers and decimals, then the whole number takes precedence. So if you were doing it to 1 significant figure, you go straight to the 3. You'd look at this and you'd say, stick at 3. So you can just write the number 3. Everything after it's irrelevant to 1 significant figure. Okay? 3.0 is 3. Show the examiner you know that just by writing 3. If we're talking about 2 significant figures, I'd be interested in the 3 and the 4, and my decision based on the next one along. So it'd be 3.5. Happy with that? Happy with significant figures? When you've got leading zeros and when you've got whole numbers. Okay. Let's have a go at those then. So significant figures. Write down the following numbers to 1 and 2 significant. Okay. So for the first one then, to 1 and 2 significant figures. To 1 significant figure then. What's the figure I'm interested in? 7. Good. The 6 makes the decision, so I go, and it becomes. Brilliant. To 2 significant figures, I'm interested in. Good, 7 and the 6, and my decision is based on. So 2 significant figures, 0.07. Good. Good. And just 1 significant figure on this one.
3.
Yeah, interested in this, based on that, it becomes 3. 2 significant figures. I'm interested in this and this, based on that, it becomes 2.8. Excellent. Well done. Sorted. Happy with that? So that's decimal places and significant figures with respect to decimals. And that's decimal notation and converting from fractions, which we did a bit of last week. What we're going to do next for 10-15 minutes is talk about percentages and compare them as proportions. Percentages are essentially the most important thing you need to know as an adult in the financial world. This guy last year, just to show you that I don't read the Sunday Sport or the news of the world, in the Times last year, I was reading in the paper and this thing came up, and this guy said percentages are the thing that most people struggle with, but it's the most important thing that you have to get your head around with respect to maths in the real world. And the first three things, his first three tips were that you have to understand what a percentage is, how to do a percentage of something, and a percentage increase and decrease. They were 1, 2 and 3 on the list of things you need to know to get on with finances in the real world. So what is a percentage? What does it mean? Good. Quite literally, percent, cent being the Greek for 100. Okay. So it's quite literally saying something out of 100, or that. Look familiar? It's a fraction, isn't it? Where we're forcing the denominator to be the number 100. That's all a percentage is. There's no trick or science to it. All a percent is something over 100. Okay, so the denominator of our fraction has always got to be 100. So when we look at 1% of something, all I'm saying is I've got this fraction 1 over 100. When I say 65% of something, all I'm saying is I've got 65 over 100. And we know how to deal with things with fractions, don't we? Yeah, because we did it last week. So let's have a look at them. Okay, percentages. One thing you have to remember is, unlike most football managers are on this planet, teams can't give 120%. Okay, there only is ever 100% of something. They will ask you questions on do you understand that percentages have to add up to 100? So 38% of the nation voted Conservative. All they're saying is 38 over 100 actually voted Conservative, which tells you, if you do a quick sum in your head, that 62% didn't actually vote for the Conservatives. Yeah? However, 66% of the nation turned out. So that tells you 34% of the nation didn't bother to vote. So you can't say it. So, exam questions that tend to come up, straightforward. The school has 750 pupils. Don't have to write anything down, we're just going to talk about, because it's just really straightforward. If 54% of the pupils are boys, what percentage are girls? They're not even asking you to work anything out. They are asking you, do you understand percentages add up to 100? So, quick sum in your head, 100 minus 54, 46% are girls. People see that and start going 75 times 100 divided by... It's like, no, it's not asking that. Do you understand percentages add up to 100? 34% of the students bring packed lunches, 52% eat in the canteen. What percent eat at home? Well, 52 plus 34 is 86. Take that away from 100 and you end up with 14% who actually go home. At no point have they involved that number. Okay? So read the questions. So let's have a look at percentages of amounts. So percentage, whatever I'm interested in divided by the whole thing. So in our case, the number of blokes divided by the total number in the class. Okay. So here, an example. What percent is 6 out of 25? So exactly the same we've just done. 6 over 25 is something over 100. Times by 4. Times by 4. 24 over 100.
Where do you get the 4 from? Why are you times it by 4? I don't understand.
Well, how do I get from... How many times does 25 go into 100?
Oh, is that why you times it by 4?
Yeah, because I'm upscaling it. Remember last week we did equivalents?
Yeah.
I have to have 100 on the bottom for it to be a percentage. Okay? So to get from 25 to 100, I have to multiply it by 4. And I know it's 4 because 4 multiply 25 by 4, I get 100.
Right.
If I multiply that by 4, when we were talking about fractions last week, so if we do the same to the top, it's still equivalent, it's still the same amount. So that becomes 24 over 100, which is, give them what they want, a percentage. Yeah? And you'll get a lot of those in Unit 2. Okay? There you go. There's one for you. So, John scores 16 out of 20 in a maths exam, and the pass mark is 75%. Did he pass? Let's do this. Let's do the maths. So, where shall I start? What's a good place to start? 16 over 20. Okay. And then, where shall I go from there? What's a nice thing to do? Something over 100. Good. So what have I done to get from there to there? So what do I have to do to the top? And I get, did he pass?
Yes.
Easy, isn't it? It's a lot easier than 16 divided by 20 times 100 in your head, isn't it? Which is why I spent all last week spending all that time teaching you equivalence, because equivalence in Unit 2 with percentages will generally be nice like that, and you'll just do equivalence and you'll get the answers straight away, rather than doing hard sums. Yeah? Good. Exam question. A farmer has 50 pigs, 35 are female. Read the question. What percentage of his pigs are male? Let's do this. Where shall I start? 50 minus 35, 15. 1 mark. 15 over 50. I want something over 100, so I multiply it by 2. Do the same there. Answer on the answer line. That's a mark, that's a mark, and that's a mark. Okay, so now we're going to start talking about percentages of amounts. So if I say, oh, there's 10% off an item, or there's 20% off an item. The way to work out a percentage of an amount is work out whatever the percentage is over 100 times whatever it is the number is. Now if I said that to you last week and it was a fraction, we'd say 20 over 100 times 120. And what you would have done then is you would have divided that by 100 first and then multiplied by 20. But the numbers are a bit big and I don't like doing all those nasty things. So we're going to use something else. Anybody know a quicker way, especially in Unit 2 where they're going to give you 10% or 20% or 30% or 15% of doing that problem?
When I do it, I take the first two numbers, that's 10%, and then look at it.
The 10% rule. It's exactly what I wanted. There is a really, really easy way of calculating nice round percentages like 10 or 15 or 20% using something called the 10% rule. Okay? All you need to do is knock the 0 off this one to get 10%. So work out the 10% amount by moving this 1 decimal place. Yeah? So £12 is 10%. I'm looking for 20%, so all I need to do is double it. Does that make sense? This is called the 10% rule, and in Unit 2, it's all you need for working out a percentage of an amount. Because when they give you the paper on non-calculator, it's got to be a nice round number. Units 1 and 3, you've got a calculator. So when they say 17.5% of something, you do 17.5 divided by 100 multiplied by whatever that number is, and you'll get a number on your calculator. As far as Unit 2 is concerned, use the 10% rule. And I'll show you how easy it is, okay? We'll just do another one. So, the 10% rule. Divide the amount by 10 to get 10%, then work out the percent that you need. So what's 30% of 70? Start off with what's 10%? 7. How many lots of 7 do I want? 3. It's 21. I've not even written anything down and I'm doing 30% of 70 like that. Which is bigger, 70% of 80 or 40% of 140? The kind of question they like. They're going to give you two choices. Okay, you're going to have 70% of £80 or 40% of £140. Which one are you going to take off your grand? The 10% rule. Okay, our first one then. Our starting point. 10% of 80 is 8. But I don't want 10%, I want... So 8 times 7, bit of those maths we talked about, is 56. Okay. Let's do the other one. 10% of 140 is what? 14. 14 times 4. No difference. Same thing. Okay. But it shows how really quickly you can use a 10% rule. If you're walking around the sales or whatever, just do the 10% and then multiply it by what percentage you're interested in. Okay. If it was a nasty number, like 75% and 45%, the rule still applies, but you just have to halve your 10%. So if we made this 75% and 45%, it's no different. Do your 10% rule, which gives you 8, okay? Multiply it by 7 to get you 56, and then that 0.5%, this 5%, is 4. So the 5% gives you another 4, which gives you 60. Can you see what I've done there? So to work out 75%, do your 70% like we just did, and 5% of 80 is that divided by 2. Yeah. If we do this one, 10% is 14. So we were interested in 4 lots, which gave us 56. And then 5% of 140 is what? If 10% is 14, 5% is 7. We add 7, we end up with 63. So when you're doing 5%, you just halve your 10% and add it on to whatever it is you're doing. Or warned you about this a few weeks ago. 40% of 9 billion. What's 40% of 9 billion? So 40% of 9 billion. It's in Unit 2. You haven't got a calculator. What's the first thing I don't want you to do?
Write down
Exactly. So 9 billion, we'll just forget about this and we'll add it on at the end. Okay? Don't write down 9 zeros and start trying to deal with 9 zeros. Okay? It's not enough ink on your pen. So 40% of 90, so £9. So what's our rule? 10% rule. So 10% of 9 is 0.9, 90p. Okay? I'm not interested in that. I want 4 lots of it. So I'm checking, can you multiply a decimal by a number? Okay? 4 times 4 lots of 9, 3.6. Yeah? And then add your word again. Does that make sense? So here, I tested that you don't write down all the zeros. I've tested you on the 10% rule and handling decimals. You've multiplied a decimal, 0.9 times 4, and you've got 3.6. And then you just put the word back for billions. Exam style question. What's 60% of £450? 2 marks. Okay? 2 marks, 2 minutes. So where shall I start? What's a good starting point?
10%.
10% rule. Brilliant. Which is?
45.
And then?
Times by 6.
Don't want 10%, I want 6 lots of it. 6 5s, 24. Yeah? Happy? No problem and no calculator required. Good. Objectives. We've done objectives 1 and 2. We're going to move on to objective 3. We're going to show you this relationship between fractions, decimals and percentages. And almost guarantee Unit 2 will have at least one question on this. Okay. So as you're hopefully aware from last week, we showed you why a half was 0.5 and 0.5 was a half. If you just project that onwards to 0.5 is 50%, because that's 50 over 100 if you were talking about a fraction, or you recognise 0.5 being 50% with respect to decimals and percentages. Yeah, so you're happy with that relationship. If you look at 0.5, we talk about that, we know that's 5 tenths, but we also know it's 50 hundredths. Okay, because we haven't talked about it a great deal, the relationship between a decimal and a percentage is all you're doing is you're multiplying your decimal by 100 to get the percentage. Okay. So, we've now got some options. Our skills at maths are building every week, okay, and we now can do problems in a number of different ways. A couple of weeks ago, no, last week, we said we could work out 2/5 of an amount, couldn't we? Because we came out with a process that could do this quickly. What did we say was the process for doing that really quickly? Good. We divide this by 5 first, because we know 5 goes into 15 3 times, and the 0 is also there. And then we multiply it by that 2 that's left over. So really quickly we can say 60, can't we? Yeah? That's what we did last week, a fraction of an amount. We've also talked about multiplying a decimal and a whole number today. So I've got 0.4 of 150. So that's exactly the same as saying that. We said we multiply this by, we make this a whole number and we multiply 4 by 150. 4 ones are 4, plus the 2 from there is 60, and then you move it, 600, and then you move the decimal place back one, if you did it that way. Okay? And then finally, we've just been doing percentages of amounts. So 2/5 is exactly the same as 0.4, it's exactly the same as 40%. So 40% of 150, we talked about the 10% rule, which gave us 15, and we multiply it by 4, and again we get 60. So without realising it, we can do a fraction of an amount, a decimal of an amount, or a percentage of an amount really easily if we want to switch between the various formats, the fraction format, the decimal format, or the percentage format, because they're all the same thing, just written in different ways, aren't they? Okay? So, we've now got options galore when we're solving problems. So let's look at this relationship between the two. I can almost give you any fraction and we can go around this loop, or any decimal or any percentage, start at any point and create the other two missing things. And you're going to need to do this, because I'm absolutely positive, bet my mortgage on it if I had one, that this will come up. They will ask you to compare a fraction with a decimal with a percentage to prove that you can do this process. So let's choose a fraction of, let's choose one that you all know, a quarter. Okay? And let's talk about the processes. So how do I go from a fraction to a decimal? How do I turn that from that into a decimal? Got a couple of ways of doing it. What does that mean? 1 divided by 4. Don't lose sight of what we talked about last week. That's all that means. It's just another way of writing a division. So when I do that, I have 1 and I divide it by 4. It doesn't go in. Carry the 1. 4 into 10 goes twice, remainder 2, and 4 goes into 25 times. So I can go from a fraction to a decimal by actually doing the division there. Okay? When I've got 0.25 as a decimal, how do I get to a percentage? Multiply it by 100. So 0.25, to multiply it by 10 and 100, I just do that with a decimal point. So it's 25%. What does 25% mean? 25 over 100, that's the definition of a percent. We've got a process where we can simplify this. Divide it by 5, it becomes 5 over 20. Divide it again by 5, it's 1 over 4. So I can go round my loop all day long with any fraction or decimal or percentage that you give me, depending on where I'm starting. Yeah? Everyone happy with that? So if they give you a percentage question that you don't like, you can turn it into a fraction and simplify it and do the fraction of an amount method. If they give you a decimal and you don't like the look of it, you can turn it into a percentage and use the 10% rule if you want to. Yeah? So there's lots of ways of answering the same question, providing you can do that. But they will test you specifically on that ability, either by giving you this table to fill in. Hopefully you can do it straight away. And this is a table that you need to know for the exam. I said remember these equivalencies. In other words, they're the same thing. So 0.1 is 10%, so what's that as a fraction? Good, 1 over 10, because that's what 0.1 means. Quarter is 25%, is 0.25, because all I do is divide that by 100. I don't even have to divide the 1 by 4. A third is 33.3 with a little dot on it. So what's that as a decimal? But we don't write 0.333, we write 0.3 with the dot. Yeah. A half is 0.5, is what as a percentage? Good. 2/3 is 66.66666 recurring, so what is it as a decimal? Good. And then finally 75% is 0.75, which is what as a fraction? 3 over 4, 3/4. Okay? They're the ones you should be able to identify off the top of your head.
Can I just ask, would we lose the mark if we wrote 0.333?
Probably. Because they're testing you on, do you remember the symbol for reoccurrences, which we covered last week. So yeah, you probably would. And the 6 as well, 0.6666. Okay? They quite often, every other paper, put that table with something or other missing on it that you've got to fill in the blanks. Typical type of question, I'll let you do those. They're straightforward. If it's 1 mark, you just need to put the answer down. If it's 2 marks, you need to show some kind of working out. Let's go then. 3/4 as a decimal. 0.75. Local knowledge, that's all you need. Nothing hard about that. 0.06 as a percentage. 6% because we need to multiply it by 100. So move the decimal places 2 along. It's the same as multiplying by 100. 6%. 35 is a fraction in its simplest form. So in its longest form, what is it?
35.
And then what do we do to it? Divide by 5 and we end up with 7 over 20. Can we simplify?
No.
Because 7 is a prime number and it doesn't go into the 20, so you can finish there. So 7 over 20. 1 mark for this and 1 mark for the right answer on the answer line. If you're working out a fraction of an amount, a decimal of an amount, or a percentage of an amount, we've got processes for doing it. So 2/3 of 600, we've got a process for doing that quickly now. 3 into 6 goes twice, and the zeros, 2 times the 200 gives me 400. If you're doing it as a percentage, we've now got a percentage method for doing a percentage of a decimal of an amount. So we've got 600 times 0.6. Move that to one place, it becomes 3600, and then move the point back. So the answer is 360. And then finally, if we're working out a percentage of an amount, we've got the 10% rule, which says 10% is 60, multiply it by 4, so 40% is 240. So if you get a question that involves a fraction of an amount, a decimal of an amount, or a percentage of an amount, you've now got processes for working out all three. Okay? Don't let them throw you. And they will ask you questions like this that you're going to get given, like deals for buying tellies or hire purchase or whatever. And one will be something to do with percentages, and the other part of the question will be do with fractions, and then another will be a decimal in there somewhere. But this one is just comparing a percentage of an amount and a fraction of an amount. So have a go at that one and say which is the larger amount. You must show you're working out. There's 4 marks for this one. This is more realistic mark-wise. So which is the larger amount? 60% of £40 or 2/5 of 55? 60% of £40. What's the trick here then? 10% rule. So 60% of 40. We start off with our 10%. So what's 10% of 40? 4. Good. And what am I after? So what do I do to my 4? And that gives me 24. So I've got £24 from that one, and then 2/5 of 55.
5 good.
Good. 5's into 55, so our technique here is to divide that by 5. I warned you about this when we were doing it last week. Always look to see if that goes in there, and it goes 11 times quite neatly. Multiply it by the 2 is £22. So which is the larger amount?
60.
Yeah? And that's what you'd write on the answer line. Yeah. Good. So that's interpreting fractions, decimals and percentages. Just going to cover something now. Percentage change. Talked about percentages. What we haven't covered is some of this terminology you see, I don't know, every day when you're watching the news. You know, the FTSE's up 2% and down 3%, and clothes are up 2% and sales are down 4% and whatever. I'm going to show you how to do percentage change really quickly, really easily. Okay? Where do we come across it? Just giving you loads of examples, we'll forget that then. Right. If something changes value, it can be represented as a percentage change. We talk about percentage increase and a percentage decrease, but a lot of people don't understand the mathematics behind how you calculate it and where they've got these numbers from. So what we're going to do now is show you the technique. Once I tell you the process, it'll never be a problem again. So, anybody know how we calculate it? Has anyone come across it before? The increase or the decrease, that's the top half of your fraction. The bottom half of your fraction is the starting amount, and that's really important. A lot of people forget that. They either put the lower amount or the higher amount. It's the starting amount. Okay, so a percentage change, how do we calculate it? Straightforward. It's the difference divided by the original amount, and that's the key. That's why the green arrow is pointing to it. And a lot of people get that wrong when they're doing their calculations in exams and so on. They're a bit confused whether to divide it by 100, whether to divide it by the new amount, the old amount, or whatever. So just keep that in mind, and we'll do a couple of examples and show you how it works. And don't forget, a lot of this is orientated around Unit 2, so the numbers are quite easy to see and juggle. If you get it in Units 1 and 3 and it's a calculator one, if it's a nasty number, 17 over 36 or whatever, and that's your percentage. Okay. So, the way to calculate it, the difference between the two amounts, divide the difference by the original amount, and then multiply it by 100 to get percent. So, here we go, Mo Farah. Before he starts a marathon, he weighs 70 kilograms. After the event, he weighs 63. What's his percentage weight loss after a race? Let's do it then. Starts the race at 70, finishes at 63, he's lost 7 kilos. Everyone agree? Mm-hmm. Percentage decrease, okay, what's he lost? 7 over 70 kilos times 100%. First thing to do, you see something like that, simplify it. What goes into the top and the bottom? 1 over 10. What's a percentage? 1 over something over 100. So it's times 10 times 10. So he's lost 10%. Okay. So he lost 7 kilos. We had 7 kilos over the original amount of 70. When we divided both by 7, it simplified to 1 over 10. We know percentages is something over 100, so we did equivalent fractions. We multiplied the bottom and the top by 10 to get 10%. If you've got it another way, there isn't an issue. As long as you get 10% and have some kind of logical process, you'll get the mark. Jane sells £120 of insurance in a day. The next day she sells £150. What is the percentage increase in her sales? What's my starting point? What shall I do first for my first mark? 150 minus 120, 30. So I've got 30. So how do I show a percentage increase? 30 over 120, my starting amount, my original amount. What can I do with that? Divide them both by 10, it becomes 3 over 12. Simplify it again, it becomes 1 over, we know what that is. And this is actually question 15 in an exam, so it's actually probably the last question in an exam. The reason it's nasty is because I've introduced a decimal. That's why. Don't let it throw you. Have a go at it. It's 3 marks. It's kind of getting towards a C grade question at the end of an exam. Okay? So have a go. See how you get on with it. If you can't do it, don't panic. You're going to get lots of practice at these things throughout the course. Let's get a couple of marks for nothing then. Let's start this. And even though it's 3 marks and you might not get to the end game, there's certainly some marks at the start you can get. So what's the starting point? 4.8. Take away 4. So the baby's weight has increased by 0.8. Happy with that? It's a mark. Never give up on these questions. Bag marks you can get. Okay? You know what the format of a percentage increase or decrease looks like. So what am I looking at? What does it look like for a percentage increase? 0.8 over 4 times 100 is what would give us our answer. This might throw a lot of people, 0.8 over 4, and there's a couple of ways of dealing with it. We know a percentage is out of 100, so if I have 0.8 over 4, doesn't matter having a decimal on a fraction, and I want to go to 100, what have I done to get from 4 to 100? Times it by 25. So what they're testing me at now is, can I multiply 25 by 0.8? Yes, I can, because I showed you how to multiply decimals earlier. Move this one place to the right and make it a whole number. So it's 25 times 8. Well, I know 4 lots of 25 is 100, so 8 lots of 25 must be 200. But I've got to move a place back. It's 20. Did somebody do it a different way?
I think I was kind of maybe getting wrong.
That's just one of many ways. Tell me how you want to do it. Any way you like. I'll do it any way you want. Just what method did you think was better?
I just did move the decimal place
Yeah?
of 8, 0.8
Okay.
to
So
have 8 and then have 40.
0.8 over 4 is exactly the same as 8 over 40. Good start. I like that.
And then simplify that down.
Simplify it down, it becomes 4 over 20, which becomes 2 over 10. 2 over 10 is 0.2. 0.2 is... That's another way of doing it. That's calculating with fractions, decimals and percentages. I'm going to spend about 30 seconds on this last bit, which is ordering rational numbers. Okay? Ordering rational numbers merely means sorting numbers that are a mix of fractions, decimals and percentages. A rational number is any number that can be written as a fraction. As far as you're concerned, a rational number is every number on this course except for pi when we come to do circles. Okay? So really what they're saying is, can you order a fraction, a decimal or percentages by swapping between the formats to make them comparable? And it might be an easy question like this one, and we did them earlier where it wasn't so easy. But a half I know is 0.5 because it's on my table. I know that's 0.45 and I know that's 0.55. So I'm comparing decimals there. Or you can compare fractions, or you can compare percentages. But that's what this requirement is. And that's why absolutely there will be at least one question on this in the exam. Okay? So they'll get you to do silly things like this. So have a go at those three. So, shouldn't take more than a few seconds because they're all quickly identifiable. So 80% is a decimal then. What's that, do we reckon? 4.8, yeah? 80 divided by 100, 0.8. Right, 0.7 is a fraction. 7 over 10, that's what it means, yeah? First column. Can't simplify it. Right, 3/4 is a decimal. Bit of confidence, everybody, bit of confidence, you'll get there, it'll come. Okay, 3/4 is a decimal, 0.75. Happy? Then this was the last bit of that question. 80%, 0.7, and 3/4 in order of the smallest first. You don't even have to convert them. That's why it's got 1 mark. Because you should now be at a point where you look at those and you can sort them in your head in seconds. Yeah? So which is the smallest? 0.7. What's the next smallest? Good. And the largest, therefore, must be 80%. Because that's 0.75, that's 0.8. Okay? And hopefully you'll get to this point where you can just look at these on a 1 marker and sort them quite quickly. Okay? Now this one I put in here because it's a combination. It's about place values as well. What's 1/4? as a decimal? Start with the smallest. So which is the smallest number? 0.2. What's the next smallest? 0.2. So 0.2 is the smallest, I'll agree there. And what's the next one? 0.25. Everyone agree? Got a few shakes of the heads. This is that misconception again, isn't it? What does 205 mean? 205 over 1,000. Yeah? Because that's tens, hundreds, thousands. So let's make this into thousands. That's 250 over 1,000. It's that misconception. Just because this has got 3 digits doesn't mean it's bigger than this one. This has got 5 tenths. That's got no tenths. Yeah? Or if we do it longhand, that's 205 over 1,000. That's 250 over 1,000. So beware of these questions. They catch you out all the time. So 0.205 and 0.25. Yeah? Remember what they mean.
You can just, someone told me once, like, you just put the zeros after the same amount and then it looks like
so you
a
could
normal
put
number.
a 0 in there, so you're saying I'm comparing 250 with 205 if you wanted to. You could put the zeros here as well. That's another way of doing it, absolutely. Just add the zeros so they've all got the same number of digits. Perfect. Yeah? Another good way. Open to ideas all the time. Good. And that is ordering rational numbers. I know we've covered a lot. We've done percentages, percentage increase, percentage decrease, done sorting of numbers. We've swapped between fractions, decimals and percentages, percentages of amounts, all sorts. Any questions on anything we've covered?